Okay, good morning again, everyone. Now, just before I get going, even though I've got a 5G modem here right beside me, I'm getting very poor. Let me just try this again. I'm getting very poor bandwidth on my, as you can see, I'm testing it here, and it's only coming up with a couple of megs. So why I'm saying this is because I don't know whether you're actually going to be able to receive this reasonably well or not. Can anybody just acknowledge that they're hearing me anyway and seeing the screen with some reasonable kind of performance, or is it chopping? Does anybody want to volunteer to speak? So you can see from my screen here, I'm only getting 3 megs, which is pretty pathetic, really. I should be getting about 100 megs.
Yeah, no, we can hear you.
Can you hear me? Yeah. Okay.
Yeah,
All right. Let's. That's good. Let's just assume everything is fine. So in that case, right. Okay. I want to finish off the messaging topic today, and then I actually want to talk about the second assignment. So I've put up the specification, and I'll talk about that as well. And if we have time, then I will start the last topic. Now, I think I might have said to you before that this was the last topic, but I just have um, one other service to cover Witchy, and there won't be a lab associated with this service. And in fact, it's not relevant to the assignment either. So I'm covering this last topic just for kind of completeness, really, to sort of round things off, so to speak. I'll explain what I mean by that when I start talking about it. I don't know if I get to it today or not. If I don't, it's not a big deal because effectively, so this is what week 10. I will definitely be finished lecturing next week. I'm anticipating. So I won't have an official lecture on week 12, although I'll just turn up anyway in case there are any issues with regard to the assignment. And of course, there is an exam upcoming as well. I haven't scheduled a date for that, but it'll either be at the very end of week 13 or at the very beginning of week 14. And I can talk more about the exam later on. Let's not worry about that for now. So to go into this topic here, and in relation to the lab, I've added 2 more sections to the lab, these 2 here. Now, these 2 sections are very relevant to the assignment, but they're not relevant to the submission of this lab itself. Once you've completed the SES part of this lab, then you've effectively finished the lab submission. But you should definitely look through these 2 sections here at the end. I guess before you start looking at the assignment, or certainly in parallel with that. Okay, so I want to finish off on the SNS stuff. And where I finished the last day, hopefully you had a chance to look over the video, was I was talking about filtering, uh, filtering with SNS. And again, just a quick recap, the idea is you have multiple subscribers. Just give me a second now. You have multiple subscribers to your SNS topic. Doesn't matter what type of subscribers they are. The image shows them all as being queues, but could be lambdas or other types of subscribers. There are lots of different types of messages being sent to the topic, and you want to filter out some of those messages because they're not relevant to some of your subscribers. Yeah, so that's what we want to try and achieve. In the language of SNS filtering, we talk about filtering policies and filtering criteria. The policy, like you filter either on the basis of the body of the message itself, where the body is, we can always treat the body as a JSON document. So you can filter on the basis of values of particular attributes, particular properties within the body of the message. But you can also filter on the basis of what SNS calls attributes of a message. You could think of attributes as sort of metadata. Might be a nice way of thinking about it. Metadata associated with a message. And so when you're sending a message to an SNS topic, there can be two parts to it. There can be the actual body of the message, and there can be attributes associated with that message. Well, you can specify filtering on the basis of attributes of a message as well. Attributes are also expressed as a JSON document. And so your attribute filtering might say something about, does a message have a particular attribute? And if so, is its value one of the following, let's say, something like that. So that's the first thing. So the policy can either be based on the body of a message or on attributes of a message. Irrespective of which it is, the way you express a filter, which we call the filtering criteria, is the same for both, okay? So there are what are called string filtering, numeric filtering, or exists filtering. And I talked about these the last day, so maybe if we just kind of fast forward to the example, rather than talking over these again. The example we started to look at the last day, but I'll revisit today. It looks like the following. So I'm using the CLI as my publisher to my topic. Here I have my topic. I've got two subscribers. I've got a Lambda subscriber and I've got an SQS queue subscriber. And that SQS also has a Lambda consumer. But you can see here now, this is the way I'm trying to document it. I want to specify a filter for both of these subscribers. And for now, these filters are going to be based on attributes of the message, this kind of metadata. And so, yeah, so if I switch over to VS Code, I'm just going to check again now. Are you still hearing me and seeing the screen fine without any breakup?
Yeah.
Yeah, okay.
Now and again it breaks up, but it's okay.
Yeah, okay. Well, you can always go back to the video and rewatch if you need to. So here's the demo example. So if we look at the stack first, stack is, as I showed you there a moment ago on the slides. But just to take from the top. So here's my topic. Here's my queue, which is going to be a subscriber. Here's a Lambda. Based on the name, this Lambda here is the Lambda that's going to be a direct subscriber to the topic because it's processing SNS messages. That's why I gave it that kind of name. Here's another Lambda. This is the Lambda that's going to be polling the queue And here's where I add my subscribers um, to my topic. And so here I'm adding a Lambda subscriber. And here's how I express the filter. So the filter is saying, look at the attributes of the message, and in particular, look for an attribute called user type. And if that attribute has any one of the following values, student or lecturer, then allow that message true. Okay. So this is the syntax that we use for defining an attribute filter. We specified the name of the attribute that we're looking for. And in this case, anyway, we're specifying an allowed list of values for that attribute. And implicitly, they are, well, not implicitly, explicitly, they are string values. So that would come under the heading of a string filter, obviously enough. Here's another subscription. In this case, it's an SQSQ subscription. And again, I've got a filter associated with it. And straight away, we can tell that it's an attribute filter. We'll see the distinction between attribute filtering and body filtering later on when we look at an example of body filtering. But again, this is also saying, look for an attribute called that. But in this case, I'm specifying a deny list. So the way you interpret this is, if the message has an attribute called user type and the value of that attribute is lecturer, then do not allow that message to go through to the queue. Yeah, and it's an array, so you can have a list of values, but I'm just specifying one value. I actually have a second filter, so you can have any number of filters. This filter is saying, look for an attribute called source. And in this case, I'm using the matching prefix filter, which is a variation on the string filter. And so what it's saying is, if the source attribute associated with the message, if it begins with either the string Moodle or the string Slack, then allow that message true. Yeah. So there's a combination here going on, but I think it's fairly easy to kind of understand what the filtering is saying. So if I had a message with a user type of student, that would get true. But if that message also had a source attribute, which wasn't Moodle or Slack, didn't begin with Moodle or Slack, then it wouldn't get through. So it would pass the first filter, but fail the second filter. So overall, it fails. And on and on, right? So you have lots of different combinations. For the purposes of playing with this, let's supposing my message, there's nothing interesting in my message because I'm not doing any message body filtering. So the message is just whatever it is, right? And here are my attributes. Where are they? Oh, here they are. Just for convenience, I've put them into an actual file. And my attributes do indeed have user type as an attribute. And the way we write these attributes, you have to, it's not straightforward JSON. You've got to write it using this sort of syntax here, but I have a user type attribute and a source attribute, and there could be other attributes as well. If there were other attributes, then my filtering would essentially ignore them. They wouldn't play any part in the filtering. Okay, so let's say we are, okay, we set the user type to lecturer and we set the source to Moodle 2025. So on the basis of that, if we go back to my filtering, clearly this one is going to stop the message from going through because the user type is was it lecture? Was lecture, I think, wasn't it? Yeah, user type was lecture. So this is going to block the message from going through. We don't have to look at the other one, but as it turns out, it's going to block on the basis of this one as well. Oh, sorry, it would allow it on the basis of this one. Sorry, it would allow it on the basis of this one because it does, the source does begin with Moodle, but this one is going to fail. So overall, the message is not going to be passed on to the SQS and therefore the Lambda that's consuming messages from that queue, it never gets invoked. Whereas up here, uh, this filter is going to allow the message through to pass through because it has an allow list, and the allow list includes the actual user type value that's specified in this array. So I've already deployed it, and just go back to here. My CloudWatch logs are empty. Let's send the message. Now, this is the log stream for the Lambda that's a direct subscriber to the topic. So that's always, if it is going to run, that's going to run very quickly or kind of immediately. Whereas the Lambda that's polling from the queue, that's always going to be delayed a little bit because of the polling action. So we'll just wait a moment or two just to make sure. It shouldn't appear on this list because it's never actually invoked because the message doesn't get through the filter. Yeah, and it looks like it actually hasn't gotten through. And if we go into the log stream, well, let's go into the stream itself. And here's the console log at the beginning of the Lambda. I didn't show you the Lambdas, but there's nothing interesting going on in there. Here's the actual message. And there's the actual message body. And you can also see the attributes down here. So they come through as well, should the Lambda actually want to process the attributes. Let's try another one where, what do we want to do this time? Let's say we wanted to get through both of the, subscribers. So if we set it to student, I think that will do it. Set this to student. We leave this as it is. And let's just check again now. So our filter says, this one says, if it's lecture, sorry, this one says, if it's lecturer or student, let it through. So it should get through there. This one says, as long as it's not lecturer, let it through. So it should get through. And it's also going to pass this one because the source does begin with Moodle. So that will let it through. And so let's send the message again. Just make one Go back to here. Now let's actually go into the message itself. Change this so that we know for definite. Now again, there is going to be a delay, I think, for this. I should see both streams popping up this time. Okay, and I do. And so if we first of all look at this one, which is the Lambda Direct subscriber, it's probably going to use the same micro VM. Okay, and that's what actually happened. So this was the first execution of the Lambda, and it's reusing the same micro VM. And here we go. Let's see, this should be, if I expand this, the message should be for user 2, I called it. So that's user 2 there. Yeah, and so that got through as we would expect. And for the SQSQ subscriber, which is this one, it's extremely slow. And there are message attributes, and the message body is somewhere buried inside here. Oh, there it is there. Yeah, so that seemed to get through as anticipated. And you could play around with it to, get it to fail both of them, etc., etc. So that's attribute, or you can think of it as kind of metadata, filtering on the basis of metadata associated with a message. The other type of filtering is filtering on the basis of the actual content of the message itself, or the body of the message. So if we move on to that, and it's the same, you have the same sort of filtering criteria. So you have this allow list, deny list for either a string value of a body property, or if a body property has a numeric value, you can have an allow list. Well, it's not an allow list, sorry, it's kind of a greater than, or equal to, that, those kind of options. If I just go back, sorry, to the filtering criteria, if it's numeric value, the conditions can be an allow list, greater than, etc., etc. Yeah, so it's the same criteria options that are available to you for body filtering. And the demo is kind of based on the lab that you're working your way through right now, where we have an S3 bucket is our publisher, and we upload files, happen to be images in our case, but it can be any type of file. Upload those to an S3 bucket. The S3 bucket then sends a message into our SNS topic. So you're familiar with this from the lab. And we've got a filter, we've got an SQSQ That's the only subscriber, for simplicity's sake, to our topic. But we want to filter the messages that are coming through. And I've decided that I want the filter to look at the name of the file that was uploaded to the S3 bucket. And the name has to begin with a certain prefix. And if it does, then allow the message to go through and consequently get to the Lambda. If it doesn't, if the file name doesn't begin with a certain prefix, then don't let the message through. And that's what I'm saying down here. The queue should only allow, the queue should only receive messages for uploads to the bucket where the file name begins with image, let's say. Yeah. So let's look at that project or app. We'll switch over to a different. And let's look at the stack file first. No real surprises. So I have my bucket. I have my queue, my SNS topic. I have my queue. I have the Lambda that's polling the queue. And then I subscribe the queue to the topic. And here's where I'm specifying, in this case, it's a body filter as opposed to an attribute filter. So we need to talk first a little bit about how we actually come up with this, because admittedly the syntax is quite verbose, but hopefully once I've explained how you come up with it, it gets a little bit easier. So what I'm showing you here is I'm showing you the console log from the Lambda when a message gets through. And I'm highlighting here, look, this is the body of the message. So the message, you remember now, the message in this case was published to the topic by S3. So that's where the message is coming from. And so we need to have an understanding of the structure of those messages that are published by S3. They are going to be JSON documents, but it's kind of dictated by the S3 service as to how it structures the message that it sends to the topic. So that's what I'm saying over here, right? What you're seeing here, and it's in serialized form because that's what happens really when essentially, I think when SNS passes the message on to SQS, then it serializes it, and SQS then eventually passes it on to our Lambda. So what we're seeing here is what the Lambda sees, but what I've enclosed in the box is the actual message that was originally published by S3 to the topic. And if we parse that message, then this is what it looks like. Okay, so now this is how what a message looks like sent by S3 to a topic. And so what you need to do is, so sorry, if we just drill right down to it. So at the outer level, sorry, I should say, yeah, okay. So at the outer level, there's a key called records. And we know that because our Lambda is always going to receive a batch of messages from SQS. So there's a key called records. And within that, if we drill down into it, we'll see a key called S3. And within that structure that's associated with S3, there's a key called Can I check if anybody can hear me?
Yeah.
Yeah. Did it go down on your side? Did the connection go down on your side? Because it went on my side, but it reconnected.
Yeah, I went for a little bit. It's back now though.
Okay, okay, you're still there anyway. Now, okay, let's pretty much guess this was going to happen, but we have to live with it. Okay, let's go back to where we were. So I was saying, we need to understand the structure of the message. And so at the outer level, the message has a key called records. Doesn't matter what type is the value associated with that key. Happens to be an array in this case. But within the structure that's associated with this key, there is a key called S3. Within the structure that's associated with that key, right down to here, there's a key called object. Within the structure associated with that key, there's a key called key. And that's where the file name is. And we want to do our filtering on the basis of the file name. So I guess what I should have said at the outset is we must find the particular property within the body of the overall message, the property that we want to define our filter on. And in our case, we wanted to define the filter on the basis of the file name that was uploaded to S3. And so I've found that property there. And you have to describe in the filter, I guess you could think of it as you have to describe to SNS how or where it should look for the particular property that it's supposed to carry out the filtering on, or the basis of the filtering on. You have to describe within the overall structure where is the property that you want SNS to perform the filtering on. And so in my case, I want it to be associated with this property here, whose key is called key, but that is within an outer object whose key was called object. That was within a structure whose outer key was called S3 and all the way up to records. Okay, so now that I know that, this then is how I actually write my filter expression, if you like. And you can see, if we kind of zoom out a little bit, here's records, here's S3, here's object, here's key. And, the value, the syntax, I'll now admit, the syntax is quite long-winded, but the value for each of these key names is always going to be this SNS.filter policy until we get to the part of the structure where we can actually define the actual filtering criteria itself. And in my case, that was a key called key. And this is where I can now actually write my filter expression. And the filter is a match prefix, which we saw already with the attribute filtering. So it's the exact same. I could have an allow list or a deny list here, but because of the way I wanted the filtering done, match prefix was the suitable one to use. And the match prefix only has one value, could have many values though. So image is the value that I'm looking for. And because I know, that key, because I know that key will contain the file name that was uploaded. Effectively, I'm saying that the file name has to uh, begin with the prefix image. Okay, so this all of this stuff here is describing to SNS how it should navigate the message object, I suppose, let's put it like that, the kind of nested JSON structure, how it should navigate it to find the particular property that I want to do the filtering on. Okay, so does it work? And so that's what you see here. Now I've already deployed it and I need to just upload. Hopefully I've got the command to upload. I think it's this one here. No, it's not. It's let's see this one. Sorry, this is the one that I want to use. So I need to know the URL essentially of the bucket, which hopefully I outputted. There it is there. Sorry, the bucket name. I'm going to keep checking now. Can somebody confirm that you're still with me? Anybody want to volunteer?
Yeah.
Yeah, okay, because I'm never too sure from my side. Right, let's sorry there actually. If I grab the bucket name from here. Hopefully that's right syntactically. Let's just go back and clean up our logs. I know I've said this a couple of times, but I'll keep repeating it, and it will especially be relevant when you're working your way through the second assignment to just make sure that you're always looking at the most recent logs. Okay, let's see if it's cleaned out. So I've got an image up here, a JPEG, and that's what I want to send up to my bucket. Now, if you can see at the bottom of my screen, I have purposefully asked it to, when it uploads my image, my JPEG image to the bucket, I want to give it to give the image file the name picture1, which means that when S3 sends a message to the SNS topic, the filter then will do its thing. And because the file name does not begin with image, then it should not pass it on to the SQSQ, and so my Lambda shouldn't run. Yeah, so okay, it has uploaded successfully. We could check inside the S3 bucket now, but happy enough that that's working okay. Now, I shouldn't really see any log stream appearing. I'll wait a couple of seconds. Oh, what appeared there? Might be some log streams from the other. No, those log streams now are from the previous example. So the log stream from my Lambda doesn't seem to be appearing, which is what I expected. Now let's upload another image, and this time we'll upload the same one, but we'll call the upload in this case image one. That is so slow. Let's just flick over to S3 for the fun of it. I do go back to editing this video. I should get rid of all these silent gaps, but I'd have a lot of editing to do if I had to do that. So unfortunately, you're going to have to live with it. So make sure you run the video if you do watch this video uh, in not normal speed. God. So this looks like the bucket here, actually. Yeah, so we can see our two images are there, okay. But let's go back to CloudWatch. Just while we're waiting for it, just for illustration purposes, let's supposing I wanted to filter here, filter messages where the S3 schema version was set to 2.0. The S3 schema, I think if we, let's see, where is it? Quicker here, record S3 schema, yeah. So that was a property, let's see, there you can see it there, look, that property, which is set to 1.0 here. What I don't really know what S3 schema refers to, but just for illustration purposes, if we did want to filter on the basis of that, on that property. Now, unfortunately, even though it's a numeric value, because it's encoded as a string, then we have to use a string criteria filter or string filter. And, that's what it's saying here, but it's the same kind of idea. Start at the top of your message body structure, which again is the record key. Then within that, look for an inner key called S3. And within the structure associated with the S3, look for this key. And then eventually we specify our filter, string filter in this case. So just another example. Let's go back to here. Still hasn't downloaded. I'm not waiting for that now, really, but we'll come back and check it every now and again. Okay, that's as much as I want to cover on SNS, really. As with every topic that I've covered, there's tons of other stuff, but we've got a reasonably good sense of it at this stage. What I mean by this slide here is we're just kind of taking a step back. Why are we doing all of this stuff? Why are we using SQS and SNS? And it was all about, you remember, it was all about decoupling your compute components so that you kind of minimize the amount of synchronous communication that's going on within your overall application. And there are various reasons why we do want to minimize the amount of synchronous communication for latency reasons, for tolerance, and et cetera, et cetera. And on the AWS platform anyway, the mechanisms or the techniques or the services that we can use to decouple were SQS and SNS. Now there's also something called data streaming, which I want to look at next. And this slide here is a slide, it's actually a slide that we saw probably back around week 3 or week 4 when I introduced the Lambda service itself. And you might remember, so a Lambda is triggered by some event. And whatever the source of the trigger is, it could be another Lambda, could be SQS, could be SNS, could be S3, could be API gateway, it could be the CLI itself. The nature of the communication between the source of the event and the Lambda is either it's a synchronous communication, it's asynchronous, or it's what's called an event source mapping, which is really this polling idea. And we saw polling when we connected our Lambda to an SQS queue. You remember that the actual Lambda service on behalf of the Lambda function, it polls the SQS queue periodically looking for messages. Well, that kind of polling approach can also be used with what are called DynamoDB streams. And that's what I'm showing you here on this image on the right. And you've actually seen this image way back, but we can probably, hopefully, make a little bit more sense of it now. So the idea here is you've got a database, a DynamoDB database, and there are operations being carried out on it, whatever. I'm showing some sort of a client. Could be a Lambda, could be anything really. That's reading, writing, updating, deleting. Well, it's really the latter three. We don't care about reads. It's the any kind of write operation, update operation, or delete operation on your DynamoDB database. You can configure the DynamoDB table such that it records every modification that has been carried out on the database. So as well as the actual database item being changed or added or deleted, we're asking DynamoDB to keep essentially kind of a log of every or each one of those actions or operations. And that log is what we refer to as a stream. Now, sometimes you might want a Lambda to process that stream, right? And so that's what I'm showing you down here. I've got a Lambda, and I want this Lambda to essentially be fed the stream of that has been maintained by DynamoDB. Doesn't matter what the Lambda does, it just needs to be told about all of the changes that are happening to the database. Now, how does this Lambda get told about them? Well, it's using this kind of polling approach that was used by SQS as well. And so it's the Lambda service actually periodically polls your DynamoDB service, asking it for any new entries that have been added to that log stream. And DynamoDB will respond with if there are new entries. The Lambda service will put those entries into an internal queue. This is not an SQS queue now. This is just an internal queue. And the Lambda service will invoke your Lambda function, passing it a batch of entries in this queue. Yeah. Uh, so that's what we call DynamoDB streams. And this could be a Lambda over here, and this is another Lambda here. And rather than they kind of communicating with each other directly, rather than this Lambda writing to the database and invoking this Lambda, telling it that I've made changes to the database and here are the changes I made. Because if we had that, we've got synchronous communication between these two, and we don't like that. So the alternative approach is as I've described. So we now have an asynchronous kind of connection between these two compute components here. And in this case, the asynchronicity is based on this kind of polling model. Okay, that's the idea with DynamoDB streams. Now I don't have, let's just go back to here. God, it still hasn't updated. It's unreal. Just going to do a manual refresh. My network gone down completely. I'm going to have to check again. Is anybody still with me?
Yeah.
Let me just check here, sorry. It's really annoying. Okay, where were we? Okay, so I guess how do we actually kind of set up this model here? I don't have a working example, And it's just as well actually because it would just take an eternity to run it. So all I have is just codec subs, but that should be sufficient because we're very kind of au fait now with um, how all of these things work based on our understanding of SQS and SNS, et cetera, and the general kind of idea behind what we're trying to get at here. So codec subs at this stage should be sufficient. So first of all, in your DynamoDB table, this is the part here. You just add this set up this stream property in the configuration of your DynamoDB table. And you specify what type of stream it is. I'll come on to what we mean by the stream type in a moment. So we set it to one of, I think there's about 4 different types. The type essentially determines how much information goes into each stream entry. Yeah. So that's fine. We'll talk about that a little on the next slide. But by virtue of this entry here now at the table, that tells DynamoDB to actually maintain a stream or a log of all of the changes that are happening to the table. Here is where, let's suppose I've got a Lambda function, which I'm not showing you on this slide, but it's just a Lambda. And here is how I'm connecting the Lambda to the stream. Okay, so I'm adding an event source, and the event source is of type DynamoDB event source. I mean, you could read this code without me having to talk over it. And I am, how does it know the table? Oh yeah, I'm pointing it at the table. And you can take this as kind of boilerplate property. Essentially what this controls is every time the Lambda service polls DynamoDB, where should DynamoDB start picking up the log stream entries from? And I'm essentially saying pick up the log stream entries from wherever you left off the last time I polled you. Yeah. So that's fine. This is how we connect them up, and this is how we tell DynamoDB to actually maintain a stream. And so all that's left really is the Lambda itself. And I think, well, sorry, before I talk about that, I mentioned, sorry, now if I go back to this slide here, I mentioned here about the type of stream, which really determines how much information should be stored on each stream, within each stream entry. And these are the different types. So there's the new image type. Image here kind of refers to the item. If you set the stream type to be new image, I'm saying that the entire table item after it was modified, that's what's put into the stream. Okay, so it's essentially kind of a copy of the new state of the table item. If you set the type to new and old, then the stream entry will contain the kind of pre and post state of the table item after the modification was carried out of it. So that would typically be an update. If it was an update operation, it would have a new and old state. Third option is old image. So you're only interested in the state of the table item before it was modified. And in the last one, you're only actually writing the partition key and sort key, if there is a sort key. That's all that's actually been written to the log stream. Yeah. So this kind of covers everything. You have the new and old. Here you just have the modified state of the table item. Here you just have the old state of the table item. Here you just have the keys of the item that were changed. Okay, that's fine. So that's well, I'm just showing you there from the code. Like if the IntelliSense kind of is kicking in and it's giving me all of those options when I'm actually writing this code. So that's the stream type. If you want to find out, well, what's the actual content of the event? Sorry, if I go back to here. So eventually my Lambda is going to be invoked by the Lambda service with an event object. And that event object is going to contain a batch of log stream entries. And so, like we always know, how do I find out what the structure of the event is? Well, just console log it and examine it and parse it if it needs to be parsed, because more than likely it will be serialized. Parse it, and that's the way you discover what is actually contained in the event object that my Lambda receives, because presumably your Lambda will need to dig into the event object to find the stream entries and do uh, some decision logic based on the contents of the stream entries. So that's all I'm saying here, really. Nothing revolutionary there. All I'm showing you here is, if you're using log streams, then there's going to be some change. There's going to be some code in your stack file, and all I'm showing you here are the imports that you need to bring into your. Is that what I'm showing you here? Sorry, down here. You need to include these imports at the top of your stack file so that it will resolve the different parts of this code here, right? These things will resolve, like this will resolve, and these things here will resolve. Okay, so there are the imports in the stack file. The actual Lambda function itself, it's of type DynamoDB stream handler, all right? So you need to import that at the top of your Lambda function. And other than that, the code is as before. It always receives an event, as we know. Every handler receives the first parameter of your handler function is the event object. And as I've already said, first thing you should probably do is console log that event object and do some parsing of inner parts of it if you need to find out exactly what information is contained within the event object. And that's about it, really. There I go back to here. That's never going to work for me, unfortunately. Sorry about that. But to go back to the lab, if you look at, so in this clearly from the title, this last section of the lab, essentially what I give you is the first project that I was looking at there, where I was demonstrating attribute filtering. Yeah. So you can download that and you can just npm install and cdk deploy and just play with it a little bit. In this one here, it's a bit back from an earlier stuff now, but here I'm just showing you how to set up a DLQ linked to an SQSQ. Now it's a while back since we talked about that, but again, I give you a project that you can just download and run npm install and cdk deploy, and you should recognize the stack itself because it's one that I talked about when we were looking at the SQS service and the role of DLQs within that. Okay, so I have now finished I finished SNS, although the last couple of slides that I've just been looking at there, they've nothing to do with SNS. These are all about DynamoDB streams, which is a separate type of mechanism for achieving introducing asynchronous communication between your compute components. So I've left them in the SNS section, but it's completely separate from SNS, obviously. Now let's park all of that and let's talk about assignment 2. So assignment 2 is about setting up a stack that has a lot of this messaging going on within it. Now, notionally, what we're going to, I give you the design for a skeleton application, which notionally is an application for managing a photo gallery. And so the idea is you have two types of users. You've got a photographer and a moderator. A photographer can upload images to an S3 bucket, and the moderator can decide whether the images are acceptable or not. Um, okay, that's kind of the basic idea. Now, for simplicity's sake, both the photographer and the moderator, they interact with the application via the CLI. Okay, there's no kind of fancy user interface. We don't want to get bogged down in any of that. I've set the completion date to that, which is essentially, I think, the Saturday after the end of week 12. It's worth 30%. Same kind of idea, just upload a simple text file called that to a link on Moodle with your GitHub repo and your video. Again, I would strongly advise people to set their GitHub repo to private until I tell you otherwise. And here then I'm giving you some more detail on the application itself. And so if I go back to here, so this is kind of a visual representation of the design of my application. And if I just go back again to here, this is this image that you're looking at. Okay, so here's my S3 bucket. And let's supposing this is my photographer. So a photographer can upload images to the bucket. Now that bucket needs to send messages to this topic every time a file is uploaded. And we've done that in the labs, so you already have this. Those messages, but only those messages, should be sent to an SQS queue. So there needs to be a filter that stops any other messages, although we haven't talked about any other messages yet. So okay, so it goes on to this queue. There's a Lambda that's polling that queue. Now you actually have all of this already from the lab. Okay, this part of the architecture you already have from the lab. The only thing you don't have, you have all of this. You don't have the filter. Now, as well, what this Lambda is doing is it's actually writing a record to the table, to a table, sorry. And or an item, I should say. It's writing an item to the table. And the item has a partition key which corresponds to the name of the file that was uploaded. So if the file name was image1.jpg, then there's going to be an entry in this table where the partition key, which is also going to be the primary key, its value is going to be image1.jpg. And there's going to be no other attributes or no other information or no other attributes, sorry, yeah, in that item for now anyway. So it's just a single attribute table, if you like. This Lambda does actually needs to check that the file type is a JPEG or a PNG, .png, okay? And if it finds that it's not one of those, so it does need to look at the message that it receives here, does need to dig into the message to find the name of the file that was uploaded to the bucket. And I think I actually gave you all of that code anyway in the lab that you're working on at the moment. It needs to check that the file name is .jpeg or .png. You cannot do that kind of check with a filter, unfortunately. So that's why it has to be done by the Lambda. If the Lambda finds that it's not one of those file types, it needs to throw an exception. Uh, Up here then is where this comes into play. So you need to have a DL linked to this queue here. And that means that when this Lambda throws an exception, and the only time it will do that is if the file name isn't of the one of the two that we are allowing. By the way, if it finds that the file name is not JPEG or PNG, it shouldn't write anything to the table, but it should also throw an exception. That means that the message then will be sent into this DLQ. And the Lambda that's polling this DLQ, it needs to just delete the image from the bucket. So it just needs to find the name of the image from the message that it receives from here, and then just delete that from the bucket. Right. Any questions about that so far? Okay, let's move on. Sorry, I'm just thinking now, is there anything else I need to tell you? Okay, let's move on. So the second thing a photographer can do is it can, what I call in the spec, it can write messages which contain metadata about the image that they've uploaded. Yeah. And these messages will have a body and they will have attributes or metadata. And if I go back to the spec, this is what a message looks like. This is what the body of the message looks like. So it'll have an ID, and that will be set to the name of the image file that they uploaded. And it will have a value. Now, what the value means, what's the meaning of the value, that will be described in the attributes that accompany the message. Now, I have said that there are only three types of attributes: a caption, a date, or a name, where the name represents the photographer's name. So there's only really three things that a photographer might want to, or metadata, that should I use the word metadata? There's only three types of messages that the photographer might want to upload or send to my topic. Either specify a caption for an image that they've uploaded to the bucket, or specify a date, let's say the date the picture was taken, or specify just their name. They're all strings anyway, okay? But there are only three permitted values for the attribute. This value here can either be caption or name or date. And I say that anyway, okay? And so it looks like in this example here that this value here corresponds to a caption that the photographer wants to have associated with the image that they uploaded, this particular image that they uploaded. Back to here. So here's my photographer, and they're writing messages directly to the topic. I've just shown you what the structure of the body of those messages is, and I've also shown you what the nature of the attributes that accompany that message is. Now, for those types of messages that are put into this topic, those messages should be sent down to this lambda here. So there needs to be a filter now introduced here, which stops these messages from getting into the queue. And this filter here should allow the messages through. And all this lambda does is it just updates the particular table item. So, if there's a record already in here which has a key called image1, then just based on the example that I showed you there, this should write a new update, that table item. And the update will be to add a new attribute to the table item where the attribute name is caption and its value is whatever was contained in the message body. Yeah, so again, just go back to here. So this message, the photographer sent this message to my topic. Eventually this got through to the lambda, and all the lambda does, if it gets through to the lambda, then we know, it doesn't have to really do any checking. What the lambda just does is it finds the value here and it takes that and this and it updates the table item accordingly. So it's effectively just adding a new attribute to the table item because the initial table item only had one attribute, that's the partition key. But now we're adding a new attribute where the attribute name is caption and the value is that. And of course that's fine for DynamoDB because it's schemaless. You can add new attributes at will. If the photographer sent another message to the topic, let's say, and this part here was set to date, and up here would be a date represented as a string. So it might be the 3rd of the 4th, 2025 as a string. Date would be written here. That would also get through to the lambda, and it would update the table item again for image1. And it's essentially just adding another new attribute to the table item, where the attribute name is date and the attribute value is whatever date was put in here. So that's the idea of this communication here. The last thing that can happen is the moderator can send messages also directly to this topic. And the purpose of these messages are to essentially communicate to my application whether an image is deemed kind of acceptable or not by the moderator. And so I've worded this as being status, the status of the image. So the moderator uploads status messages to the topic. Those messages, we'll look at the structure of them in a minute, but those messages should only be sent down to this lambda here. They shouldn't be received by this lambda. They shouldn't be put into the SQS queue. So that's why I've written filters here. And what this lambda does is it's very like this one really. It simply updates, it adds a new property, adds a new attribute to the table item, where in this case the attribute will be status and the value will be whatever was contained within the message. So if we look at these messages, what do they look like? They look like this. So they don't have any accompanying attribute, but the the messages do have the message body does have a structure, and the structure is what I'm just highlighting there. And the important parts of the structure are is really in here in this inner part. So there is an update key, and within that there is a status key, and the status key is going to be a string. And I say in the spec there are only two valid values for this string. Where do I say it? Do I say it somewhere? Let's say the message should trigger. Do I say it up here? I should have said it. Maybe I don't. Well, I actually kind of see it here. Really look. Pass or reject. Yeah, pass or reject are the only two valid values for the status. Okay, and so these messages, again, if they get through to the Lambda, all the Lambda has to do is just dig out the value that's here, which is going to be pass or reject, and the filter would only have allowed that through anyway. So it just simply updates the table item. What table item? Whatever is specified for this property up here, because ID in throughout this application represents essentially the name of the file, which also happens to be the partition key of the corresponding table item. And so the Lambda, what Lambda is talking about? I'm talking about this Lambda here. It's just going to be adding a status attribute to the corresponding table item. The status attribute might already be there, in which case it's just changing it. It's really the same difference. They're both update operations. And that's all that Lambda does. It's pretty simple, really. Does it have to do any checking? I don't think it has to do any kind of validation first. You can think about that yourselves, but like if it gets through here anyway, we know it's a legitimate message, if you like. So in terms of processing, it's got very little to do. Now, what's going on over here then, this is kind of the final part of it really, is this database streaming that I'm talking about. And so what the purpose of this Lambda is to send an SCS, send an email back to the photographer, just telling them that the status of your image has changed and here's the new status of it. Now, we can assume our application only has one email address that it can send to. So just for simplicity's sake, our photographer only has one email and there's only one photographer, but that's fine. So this Lambda sends email messages, and it knows when to send an email message because of the link that we've got here. Now it does probably need to check that the change that has happened to my database has been a status. The status attribute of the table item has changed. It's not going to be sending emails when the moderator sends this message here, okay? Because when the moderator sends some new additional metadata about its image. I was hesitant to use the word metadata there because I used it earlier on as well, but let's just stick with it. Image metadata. Yeah. When the moderator sends image metadata to the topic, that will eventually result in a change to my table, which means this lambda is going to be triggered, but it needs to check to see, well, was it the status attribute of the table item that has changed? If it isn't, then just ignore it. Don't send out any email. And as well, I think this lambda might be triggered when this lambda here actually adds a new item to the table. So the simplest thing would be all it does is check to see, is it a status attribute that has changed within the table item? If it's not, then ignore every other log stream entry that it has been told about. Right. Go back and read the specification. Now, if I go back to the specification, yeah, give you kind of a breakdown of the marks and giving it to you slightly differently. Kind of broke it down on a basis of each of the lambdas. But of course, the lambdas themselves, functionally, they're not very difficult to write because in the main, they're just doing database updates. The big part is the filtering, though. You need to get that right. In fact, as I reflect on it, sorry, the filtering here. As I reflect on it, the filtering, well, it's maybe 40% is probably right, but it certainly is a significant part of it. And by messaging here, I mean, the actual infrastructure that you've got all of that connected up properly. The more I think about it now, maybe there should be slightly more going for filtering. Maybe it should be 50%, but I'll leave it as it is for now anyway. As always, you should approach anything incrementally. My advice, for what it's worth, if I go back to here, my advice is to start here with this lambda here. Okay, so get this part of it working. I can draw around it. Yeah, get all of that working. Just forget about the DLQ, okay? And you don't even have to have any filtering initially. So get all of that working so that it updates to the table. Forget about all of this stuff over here. Once you've got that working, then maybe this is obvious to you as well, but then start looking at, well, I suppose you could look at this lambda. So bring in your DLQ, get this lambda triggered and get it to delete the image from the bucket. There's no filtering needed at all so far because we're only sending one type of message, so our topic is only receiving one type of message. So I now have these two lambdas working and my table is being updated. I now move on to this message being sent into my topic. So I will go away and write this lambda. And I now need to probably bring in my filtering now because I've got two types of messages going into my topic and I want to make sure that only certain messages go here and only certain messages go here. And if I get that working, if I get the filtering working, then it's easy enough to write the lambda. It's just doing a table update. So I now have these two lambdas working and the filtering is working as well. I then take this message being written to the topic, write my lambda down here. I may need to go back to these filters now and change them. I don't know. You'll only know by testing it, but you certainly will need to define a filter for this connection here because the messages, these other messages up here that are being written to the topic should not arrive down here. And again, what the lambda does is pretty trivial. So you're spending a lot of time going back and forth checking that your filtering are still working. Because let's say we're now at the stage of developing the processing of this message, and we get it working fine. Go back then and start uploading an image and make sure that this Lambda here is not triggered as a result of an image upload. And certainly this Lambda is not triggered as a result of an image upload. And assuming you've got all of these working, then the final thing you should look at is this part over here. Okay, that would be my advice as to how you should approach it. Where are we on time? 13:52. I'll pause. Obviously, I guess you'd need to read the spec, but I'll just give you an opportunity anyway for questions, if there are any questions so far or at this stage. No. There I go back to AWS. Still hasn't uploaded. My God. Right. I'm not going to continue on. So there's only one. If I go back to the website, sorry, I'm jumping around a little bit. If I go back to the website, all that remains for me to cover is this section here, which I'll start next week. I might get through all of it, I'd say, next week. I mean, if I have a reasonable network, I certainly will. But as I did say at the beginning, what I'm covering here is not relevant to assignment 2, and it's not relevant to the exam. So I'm only covering it for completeness sake. It's probably a mistake for me for a lecturer to say to students, the stuff that I'm covering in next week's lecture will never be assessed. So that probably means you tune out straight away, but hopefully not. I'll try and make it reasonably interesting for you. Essentially, what we're going to do is try and imagine we have a full stack application. We know how to create a serverless web API, but let's suppose we've got a front end application as well, like a React app, and that communicates with our web API. And we want to pull in the deployment of our React app into our overall stack deployment. So it deploys both the front end and the back end, and critically, it actually connects them up dynamically. And the very last thing I would look at is supposing we want to have a custom domain name associated with our full stack app. How do we do that on the AWS platform? Okay, that's for next week though. So for this week, go back to this lab. If you haven't already submitted it, make sure you do. Start looking at these two sections here, because you now know that there is a DLQ part of the assignment. So that's why you just need to play with this part of the lab. There's a lot of filtering going on in the assignment, so you should look at this part of the lab. This only covers attribute filtering. Attribute filtering is not sufficient though for the assignment. You probably will need some body-based filtering as well. And then start working on the assignment, I guess. Right, there are no questions. I won't delay you any further, so I'll finish the lecture at this point, and I'm available tomorrow morning as usual for the labs. Thanks, bye-bye.